The question says, how much heat energy is required to raise the temperature of 2 kilograms of water from room temperature, 20 degrees C, to its boiling point, 100 degrees C? And then it gives us a specific heat capacity of water. So in previous class students, we talked about how delta E equals Q plus W, and we found W as negative P delta V. In this case, we want to find Q. And in this case, we want to use the equation for the specific heat capacity. So Q equals M, the mass in grams, times C sub S, the specific heat capacity, times delta T, the change in temperature. Delta T, like other delta variables, is the final minus the initial. So in this case, we have 100 to 20, so the change in temperature is 80 degrees Celsius. So 100 minus 20, which is 80 degrees Celsius. Note that this mass has to be in grams. If you weren't sure, just check the unit of the C sub S. The mass unit of C sub S is grams, not kilograms. So we do not want to plug in 2 kilograms. We want to plug in 2,000 grams. So Q is equal to 2,000 grams times the specific heat capacity, 4.18, okay, joules per gram degrees C, times the change in temperature, which is 80 degrees C. When we do that math, we find that Q is equal to 670,000 joules, or if you wanted kilojoules, because it's such a big number, 670 kilojoules. Just divide this by 1,000. Note that your answer should have 2 sig figs because your mass has 2 sig figs, and this is kind of ambiguous. Sig figs not super important here, but just worth pointing out.